Okay, let's get started. I don't have any announcements. Are there any questions? No questions? Oh, okay, so I do have an announcement. I'll try to get solutions posted for assignment 1 sometime this weekend. I have the code that the TAs gave. I'm just going to take a quick look at it, and then I'll put solutions up. But any questions before we, yeah?
Is like the assignments like hit or miss? Like if you get the code like completely right, it's like pass
Yeah.
test cases. And like doesn't pass a couple test cases, is it like a 0?
On those particular test cases. So that's actually a good question. It's right now, the TAs are the ones who are grading the assignment. I don't have a grader yet, but I am in the process of hiring an actual grader. The TAs are not supposed to grade things, so that's why I made the grading easier for them so that they can just run the program and then it'll tell you this many test cases passed and that's the grade you give. What I may do once I actually get a grader is to have part of it be like test case based and then some other part of it to be, you used good comments throughout your program, or you had good program structure, or something. So that's what I'm probably going to do in the future, because I hate having a binary grading system like that, because even if you're like one character off, then you miss the entire test case. But I need to have a balance between not making my graders work more than the hours they're allocated for, and sanity on our part. So that's what it'll be for the first 2 assignments. I don't know what it'll be for the 3rd and on, but I hope it'll be kind of a part-based thing, yeah.
Because I think I had trouble at the end of mine because it kept coming out as 0. Checking my thing, and like every time I put a test case in, it coming in 0. And like, I don't know, and I didn't have enough time to fix it. Kind of just turned it into something.
Okay. Yeah, so the TAs haven't graded the assignment yet, so when you do, if you don't get full points, what you should expect is to get a short little comment from the TAs to say, oh, you missed them because you probably should have done this instead of what you did here. If you don't get that and you didn't get full points, send an email to the TA. And then they can take a look at it and give you personalized feedback. Other questions? Okay, so I mentioned a while ago in the second set of slides that I'll return to this line right here, this using namespace STD thing. So we get this, we get every line in this program pretty much except for the using line and the return 0 line. So I'm only going to talk about the using line today, very shortly. So anyone know what it does? So let's just put our favorite program in here. And then just a quick question. Does this program compile? Yeah. It's our usual program. So there's nothing special about this. This line is the worst line in C++. It's overused and it's dangerous in some sense. So what does it actually do? Does anyone know?
The namespace is standard for every single operator.
Almost. So the literal only purpose of this line is to let you type less. It doesn't provide any functionality to your code. All it does is allow you to type less code. That's the entire purpose. If you didn't include this line, it's not going to actually compile. So because it says, oh, this cout, I don't know what this is. And so it provides a thing to us that says, oh, did you mean std : cout? So what this line says is, anything that involves something in what is called the std namespace, the standard namespace, if you write this, it says, if you have anything from there, you don't have to type it. So normally what we would do is, if we didn't have that line, we would have to say std : cout. So like for endel or any other function in the std namespace, you would have to do this if you didn't include that line. Question for you. Why is this line so bad? That's not actually really dangerous. It's just maybe you're a little lazy, but it's not actually dangerous. What's dangerous about this? What if we had two different namespaces? We did a using namespace on both of them, say std is one of them and another namespace for another one, and both of them have a cout function. And I did a using namespace on both. When I write cout, which one is it calling? Doesn't know, right? So it just has no idea. So, but we all want to type less, right? So what is a better way to do this? So instead of saying this, what usually people do is instead say using std : cout. So all this does here is saying, I don't want to have to, whenever I want to use cout, I don't want to have to type std : If I do cin and I just had it like this, then I do have to type it. So here you're just saying, I want to type less on this, on this, on this, instead of the entire namespace, which is better if you have multiple namespaces. Yeah.
So could you use that for the same thing as new line or other std functions?
As what?
If you use new line, you can do that up there as well.
You mean endl?
Endl.
Yeah, it's the same thing. Yeah. So I can do using std endl and then using std cin. You can do that. Yeah. But for this class, it's absolutely okay to do this, even though I hate it, because we're not going to use any other namespaces in this class, so you don't have to worry about that. But just know, if you're going to be using this in the real world, don't do this. You had a question?
So the problem you mentioned about cout, if it belongs to another namespace.
If it happened to, yeah.
Then you type std : cout.
Yeah.
And then you want to use cout from another namespace, that'll be an issue.
A different namespace : cout. Yeah.
So you have to leave that out, and then whenever you use cout, you have to use std : cout.
If there could be an ambiguity somewhere, and in fact there may be a compilation error, there might not be. So it's just a little dangerous if you're doing this with multiple namespaces.
Would std from another namespace, cout from another namespace serve a different function?
It could, because they can define. We'll be able to define functions to name them whatever we want and to do whatever we want. Cout doesn't necessarily mean print to the screen. It could have a totally different purpose.
So it's like different libraries?
Yeah, if you're using a different library, yeah, of code, yeah.
Can you list the different standardizations that you're using in the same way that you can initialize lists of like things? So instead of doing using std : cout and then do comma space.
Yeah, you can do that too. Yeah, you can do this, I'm pretty sure. So let's actually see. Okay, so remember when I mentioned C++11 last time?
Yeah.
So the most recent version came out in 2017 called C++17. Apparently, if you want to do this, then instead of on multiple statements, and you want to do it in one statement, then you have to use C++17. And remember how to do that is when you compile, you say -std equals C++17, and then it should have no problem. So yeah, I actually didn't know that, so that's something new I learned today. Any questions on this, just at a high level, what a namespace is and how everything works? Okay. You don't have to know exactly what a namespace is. We're not going to really talk about it in this class. Okay, so last time we were talking about a whole bunch of different stuff, and we landed here on constants. So we talked about variables quite in depth, but if we want to have something that shouldn't ever change, like the value of pi or e or mathematical constants or anything really that shouldn't change, then we should make a constant for them, because we don't want to accidentally change the value at some later point. And the way that you do that is by creating a normal variable as usual, but sticking a const at the very front. So if I want a tax rate of 7.75%, then I would just make a normal variable called double tax rate and stick a const on the front of it. And so if I want to say tax rate at some later point equals 0.1 or whatever, then that'll give me a compilation error. So that won't even compile because I'm trying to modify a const yeah, so I don't like the name constant variable. Sounds like a oxymoron, I guess, but I'm trying to modify a constant in that example. Yeah, so here's another one. You can do it with ints, you can do it with strings, anything that you actually want. You can see here that the variable name is all in all caps here. That's just a convention. You do not have to have constants be named in all caps, but that's just the usual convention. So if you are going to make a constant, put it in all caps because that's how other people are used to it. Yeah, so if you want to create a constant, then you have to give it a value when it's created, because if you don't give a value to it, then at some later point, is that a modification to the value if you're trying to assign to it? Are you trying to modify it, or are you trying to initialize it? So what C++ people say is just initialize it on the same line as you declare it. So I can't just say constant class size semicolon and then later class size equals 24. So that's not allowed. Yeah, and there's an error if you try to modify it later. But I can access it. So I can read the value in there, but I can't change it at any other point. So why is this better? Because, so why is this better? So let's look at this instead. So suppose in my code, instead I did this. So this is just the sales tax. Let's actually just initialize it here. So instead of doing this, let's just comment out this line and say 0.0775 here. What's better about declaring the constant and then using the constant there? It does effectively the same thing. What's better about doing this? Sorry, about the previous way, which is this one.
So someone who's reading your code can know what's going on.
Right. So the variable name is really useful here in that if I'm going to be using tax rate here, and I can just read the line and say, oh, purchase price times the tax rate, that's the tax on whatever's being ordered. Yeah.
You could also say if you have a lot more code that has tax rate appear multiple times in the code, you can change it all at once right on the top there instead of having to go find it at the same time.
Exactly. So if I am going to be using this tax rate over and over and over, instead of having 0.0775 everywhere in the code, I can just have it in one place. And then if I need to change it, I only need to change it in one place. So it's not, we're not getting any more functionality from using const, but it's a lot better than not having it. Okay, so any questions about const? Yeah.
Can you use it with a CN? Would that be allowed?
Good question. No. So what happened? So that's actually a very good question. So let's just look at this. So let's just try to consider this. So what is happening here? So we don't actually see what's happening here, but in the internals of CN, an assignment is taking place to the variable. And so because that is not on the same line as where we declared this tax variable, I can't declare this tax variable const, unfortunately. So for that reason, we can't use const with CN here. And I hope it'll obey what I'm doing here. Yeah, so it'll give us errors here. So, well, first off, I didn't give it a value, so that should be a obvious error. But even if I compile this, it won't work because if you actually bother to go through and read all these, it won't actually work. So if you take a look here, although it's kind of hard to read here, if you look at this, we're going to be talking all about what this actually means, this ampersand right here. But notice, what type is being passed into this function? Well, in that one case, an int, right? Is it a const int? No. And so what happens here is this ampersand here means I can modify whatever was passed in to the original value. So when I'm looking here, when I'm doing this cn thing, it's actually modifying this tax variable right here directly. And so because of that, I can't actually make it const, unfortunately. But what I could do instead is say, oh, I'm going to do this, and I'm going to say const real tax is equal to tax, and make it double. So here, I'm responsible for getting the input in, but real tax's value never changes. So I can assign to a constant and never change it later, but I can't use cin with it. So it's a bit of a workaround. Okay, any questions on how const works? Yeah.
I'm just sort of thinking, like situationally, like when would you use something like this? Would it be like for the menu assignment?
Right. Yeah.
So you would like open this program at the beginning of the day and set the tax percentage for the day, and you wouldn't be allowed to change it for the entire day. I mean,
No. It's when you compile. So when you compile, and then you can run the program as many times as you want, and it's still using those same values. If you need to ever make a change, then you recompile and then just use a.out again. So it's not like on a day-to-day type thing, but unless you're compiling every day, yeah.
So later, if you change the value of tax, would there be an error?
Oh, I'm not sure what you mean. Oh, you mean if I change like real tax?
You change the tax to like tax plus.
Oh, okay, yeah, good question. So let's just look at this. Look at this line on line 9. Is that an error? Ignore 10. Just look at 9. Is 9 an error? No. Why? Because tax itself is not const, because we declared it double up here. What about line 10? Yeah, that's going to be a problem. So if we actually compile, we can actually see this happen. Yeah. So for this variable declared here, there was an error right here, which is the line 10 that we had. Yeah, so you can always modify a non-const variable, but you can't modify a const variable.
Doesn't modifying the non-constant actually affect?
Good question. So what happens here is when we do the assignment, what happens is it takes the value in tax and copies it over to a brand new location in memory for the constant variable. So let's just say we enter 7.5% for tax right here. So 7.5% is living where the tax variable is, and a different 7.5% is living with the const variable, which is kind of interesting. We'll somewhat later we'll talk about how could you say I'm going to have only one instance of that 7.5% right here. So I'm going to have a variable called tax refer to it, and a const variable also refer to the same location. But for now, they're completely separate memory locations, which is why we can accomplish everything but line 10 here, because we have two separate locations. And so one is not interfering with the other. Okay, any other questions about const? Okay, so last slide on this, thankfully. So just some programming tips, I guess. So programming style is just how do you actually lay out the code in the file itself. Yeah, so it provides info to the reader about how did you organize the program. So we haven't really talked about yet, because we don't have all the concepts yet, of how do I lay out like this part of the code versus this part of the code, how should I structure things. but just keeping that in mind is very useful. So a person's the only thing that's going to be reading this program, right? Reading the English part of this program. And so to make it visually nice is really useful. So let's just look at this program. Could I, for example, do this? Yeah. So remember, when I'm compiling C++, all it is it's just a bunch of characters in a row. Maybe there's a new line character somewhere, but it's just characters in a row. And it's just looking for the semicolon for each of the statements. It doesn't care whether or not there's a new line somewhere. So if I actually compile this, it'll compile. So it doesn't matter whether or not I put it on multiple lines with respect to making the program work. But do you want to read a program like this? No, it's just terrible. So what is very recommended is putting the curly braces on the same indent. We haven't gotten to indents yet, but we will in the next set of slides, I promise. But it's just lining everything up and tabbing everything in, lining all of the lines up to make things a lot easier to read. Because I've seen submissions of students like this before. And so you can read it, but do you want to? Maybe some of you do, but I wouldn't want to read something like this. So just keep that in mind. Try to make it look nice. Because other people will be reading your code. And just be consistent, right? So don't adopt one style and then use a different style at a later point. So things that apply to more than just programming. But any questions on C++, those slides at all? Yeah.
Why is it that some people leave the bracket on in main, but some people put it on like a new line instead of that?
So everything in the programming world is the source of contentious debate. Literally, the most debated question in all of programming is, where should I put the curly braces? Should I put them on the new line like this or up here like this? So I don't care, but just adopt a style. I prefer this, but I don't care what you actually use, as long as you can read it and your peers can actually read it. So it actually doesn't technically make a difference, but it's just where does it, you can use either one. And some people prefer this one, some prefer this one. Other questions, yeah?
I've seen on a lot of, it'd be more like INI files and things like that, but comments off to the right, off screen, off to the right, do they, like, is that common, or is it more common to put them in line prior to or after the stuff you're talking about?
So it depends on what you're trying to do. If you have a really long line of code, say like this one, and you put a comment over here, then you're going to have to maybe scroll to actually read what the comment actually is. But if you have a short line like this one on line 7, then it might make sense to put the comment here. So some languages adopt a style guide where you should refrain from having a certain number of characters or more on a single line at a time. So like Python, I think it's like either 80 or 90 characters per line, so that it's not too long of a line to actually read. I don't think there's one for C++, but just adopt a style where it's easy to actually read your code. Remember, don't make it difficult to read your code. Try to make it easy. Any other questions? Okay, so let's actually get on to some new cool stuff. So what we've done so far is, so remember, what types of programming are there? There are two types. There's object-oriented programming and there's procedural. So which one do you think we've been looking at so far? Procedural. So what is procedural again? Yeah. Yeah, it just goes from it just blasts through from the top all the way to the bottom. But what we're going to do here is we're going to have some branching, as it's called. And what that means is if some condition is satisfied, then we'll execute some code. And if it's not satisfied, then we won't execute that code. Could we do that before without these decision things? Could I have a situation where some condition satisfied, then I will execute it, but if it's not, then I won't? Could I do that before? No. So in fact, we are getting more functionality than what we had before. So decisions are really useful. So remember the bools from before. What is a bool again?
True or false?
Yeah, it's a true or false value because that's literally what all of the decision stuff is all about. So before I talk about decisions and stuff, I need to talk about relational operators. So all they are is just to compare two values. So if I want to compare 5 against 7, then I can use any one of these 6 operators, for example. And so let's just do a quick example. Is 5 greater than 7? No. Is 5 less than 7? Yes. So if I maybe just see out the value 5 greater than 7, what do you think would be actually outputted? 0, but actually what is outputted is? False. And if I did 5 less than 7, then what do you think is outputted? True. So what relational operators do is compare two values against each other, and then it'll give back to us a what? A bool. It'll give us a bool, either it's true or it's false. And then we can use any one of the 6. So maybe we, so what is the most important number in all of the existence of the universe? 42. So let's just have a program which outputs something based off of what whether the number was 42 or not. So let's just have a const int x, which is 42. And then let's just have the user enter a number, and then it'll print true if the user entered 42 and false otherwise. So let's have a int y that the user will input. And then, so if I compare, so how should I compare x and y to see if the user entered 42? How should I compare them? With equals. So what if I did this? So remember, it's going to give us a bool. So I'm going to call it b. So what if I did this? So what is wrong here? What does a single equals do? Assignment. So how do I compare the values for equality? That's with 2 equal signs. So if I want to compare the values in x and y, I need to do 2 equal signs. And then let's just see out b, and then maybe a new line to be nice. So let's compile and run. If I enter 43, it'll actually, oh, okay, so it'll print 0. Oh, that's interesting. So you were actually right, it would output 0, but what does 0 correspond to? False. So are bools also integers themselves, just the bool values? Yeah, so remember, false is represented by 0 and true is represented by 1, let's say. So they're actually interchangeable. So, and then if I run and I put 42, it'll print 1. So any questions on just using this? Okay, so yeah, that should be pretty straightforward. Yeah, so here's just some examples. 12 greater than 5 is true. 7 less than or equal to 5 is false. And then here's some examples with 10. Yeah, so then we could save them to a bool variable. I'm not sure why it doesn't print false and true here. I'll take a look into that. But you can save it to a bool variable. So the key thing that most students miss or get wrong is that they want to compare the values of 2 things, but they use a single equals instead of double equals. So if you want to compare the values, always use double equals. Okay, this isn't that important, but if you have a line which has a whole bunch of different operators in it, so maybe it has a less than, then a double equal, then a greater than, you may want to know which one's actually executed first, because maybe if you did them in a different order, the result may be different. So what happens here is it'll scan left to right, let's say, and it'll look for the highest precedence operators first. So if there are any of these operators, it'll execute those. So if we have, for example, so x greater than or equal to y. I'm not sure how, I'm not sure how we're supposed to do this without further concepts. We're not. I guess we're not supposed to really figure out how to actually use this to our advantage without additional concepts. So the reason why I say that is I need something like to say x is greater than y and x is equal to y. So just by looking at this, and is not something in C++. But if you just looked at this, which one of these two should be executed first, based off of the hierarchy over here? Yeah, the greater than or equal to 1, because it has higher precedence than the double equal one. There are a whole bunch of different rules about like when things are going to be executed versus when things are not. But in general, if there's a hierarchy like this, the ones of the highest precedence are executed first, and then the ones of lower precedence. We're not going to actually use this very much, I don't think.
It's like an order of operations.
Yeah, it's like PEMDAS for arithmetic, but it's with relational operators instead. That's the only difference. Okay, so here's where things get really interesting. And finally, we get some additional functionality. And it's something called an if statement. So remember before when I said statements are usually on one line and have a semicolon at the end? But then I also said that there are counterexamples where they don't have a semicolon or they're not on just one line. This is our first counterexample. So an if statement, all it is if some condition is true or something is satisfied, then the code corresponding to the if statement, and we'll see examples, is executed. So if something is true, then we execute the code. If at that point the condition is not true, then that code corresponding to that if statement is not executed. Okay? So all it is kind of like a gate to say, I'm going to only allow you through if the condition's satisfied. So like here, if it's cold outside, wear a coat and wear a hat. So does this tell me anything if it's not cold outside? No. So I might actually wear nothing. Yeah, well, not like that, but if it is cold outside, all that we can infer is that we wear a coat and wear a hat. If there are other conditions after it, maybe we can infer more, but this is all we can infer from this. So how does an if statement actually look in C++? So the syntax of it is if parentheses some condition, and the condition part is something that evaluates to a bool value. Either it's a bool itself, or it's a relational operator, or anything else that gives you a bool back. Okay? And then what you have after that are curly brace, so open curly brace, and then a whole bunch of statements inside of the ifs, inside the curly brace, and then ending curly brace. So if this condition is true, then all of these statements will be executed. If the condition is not true, then none of those statements will be executed. So let's go back to our example. So let's say that we want to print, so what should we print if the user does enter 42? Let's just make it simple. Correct. So if the user did enter 42, what should we say? C out, correct. So how would I write the if statement here? So if just true like this? So the user's if the user's input, which is y in this case, equals 42, then what should we do? I know I did it wrong. So, but I want you to tell me what'll actually happen here. What can you infer what will happen? Yeah, so this is actually something really interesting. Yeah, so ignore the warnings. So if I enter 42, enters correct, so that's expected. So what can we infer about assignments? They have some kind of trueness that's always true. So I don't really know how to say that. But yeah, so there's clearly something wrong here. What should I have done instead? Double equals. Do you think a lot of people do this instead of double equals? Yeah, so here's something that not many people know of, but it's something called a Yoda conditional, okay? So instead of doing this, flip the operators around. So what you do instead is this. What do you think will happen here if I just left it like this? Yeah, it'll actually give us a compile error because I can't assign to something that's not a variable, which is 42. So here, this actually gives me a compile error that I'm not silently doing something wrong here. It'll tell you you're doing something wrong. And so now I can fix it. So this will definitely save you some issues down the road. So I always advocate use Yoda conditionals because you can't get it wrong here. But if you flipped them to the way we had before, you could get them wrong. So any questions on what an if statement is supposed to do?
Think of the name Yoda.
Oh, what, sorry?
Do you think of the name Yoda?
No, I didn't think of the name, unfortunately. I saw it online and I thought it was just brilliant. So it's just perfect. Okay, so right here is just a pretty picture of the behavior of an if statement. So we come down from the top and we look at the condition. If it's true, then we go through the statements. If it's false, we go around the statements and we don't execute any of them. So it's just a pretty picture of what we did before. So here are just some examples. So if the score that was entered, let's say, is greater than or equal to 60, then we do this cout statement. If score is greater than or equal to 90, set some value, and then do a different cout statement. Okay, what if I did this? So let's just go back to this first example right here. So what's the difference between this first example and this second one right here, other than that there are two statements instead of one? What's the main difference? What about these? Are they present in the first example? No. So what if I did this? You entered the right value, let's say. So let's just compile this. Oh, no warnings, great. Does no warnings mean something good? That I did it correctly? Oh, so let's just see what happens. What if I entered 43? What do you think will be printed? So in some languages, this is correct, like Python. Python is based on an indentation. What can we infer about C++? Is it based on indentation? No. And in fact, when we wrote everything on one line, that clearly shows it's not based on indentation. What should I do here instead? Put the curly braces. So if I put a open here and a close here, then is this guaranteed to work now? Yeah, because I wrapped everything in the curly braces. So what we can infer from the if statement is it just looks to the next block of code. Either it's braced in curly braces or it's just a single statement. The next thing, whatever it is. So do you think I advocate doing this first example with no curly braces? No, because I've seen students get tripped up when they try to indent two things and just have an issue that the second one always prints, whereas the first one is depending on the condition here. So always, always, always use curly braces. I mean, it's only two characters to put. Is it really that much work? So, but it saves you hours of maintenance work. Okay. So if is a keyword, so it has a specific purpose. Don't put semicolon after the condition part. I actually invite you to actually figure out why it says that. So how could you figure that out? Whether or not, yeah. Yeah. So I invite you to figure out what'll actually happen if we put the semicolon after the condition. Does it not compile? Does it do something else? So I invite you to figure out what actually happens there. Don't forget the curly braces, and don't confuse assignment with comparison, as I've said before. Okay, so if you want to test for equality, that's fine for integers. There's just a little bit of an issue with floating point, because if something is like true, the same value up to 10 decimal places, but not at the 11th decimal place as some other value, are those really the same value or are they different values? So it just might be an issue working with floating point. The usual technique to avoid exact equality here is to use greater than or equal to tests. That's the usual way to do it. Or what you can say is, here's the target value, but as long as it's within some really small range around there, then I consider that good. But hopefully we won't ever encounter such a thing like this. And because I've never seen an issue with this, but it's just, it could come up. Okay, so remember, 0 is false, anything non-zero is true, but we can just say 1 is true to make it easy. Yeah, so an expression may not just be a comparison, it can be a single variable. So it's not just like x greater than y returns true or false. It could just be the actual value itself or a whole expression. But it's just the value 0 or something evaluated to 0 is false. Or something that evaluates to non-zero is true. Okay, where's this? So I'm going to return to this. I want to get on to if-else because it's kind of necessary for the labs and everything else. So remember when we had the example here where we said if they enter the right value, then we print correct? What if they put the wrong value in? What'll happen with this program as is? It just doesn't print anything. But maybe we want to actually print something to the user to say, oh, you entered the wrong value, run the program again and try. So if they did enter 42, then we come down in here. But after that, I want to say if they did not enter 42, then I want to do something completely different. So I could say perfectly well in this case, if 42 is not equal to y, then I can say incorrect or whatever. Right? So does this work for getting the right value as well as if they enter anything else? Yeah, there's nothing wrong with this. But what is the potential problem? What if I wanted to change this 42? I should use x in both of these cases so that we're referencing the variable from before. But what if I did something different here? What if I needed some additional condition here? We don't know what and is in C++ yet, but maybe we have some other condition here. Wouldn't I have to repeat it down here? Yeah, that's kind of annoying. So what we can do instead is we put an else statement here. So what else means is if this condition is not satisfied, then everything else, anything else, will filter down into this else block down here. So if they enter anything other than 42, then the else set of code is executed. So if we actually compile this and run, we can see this in action. So if we enter 42, we get the right value. If we enter 41, then we print incorrect. And in fact, if I enter anything at all, it'll still print incorrect. So it's checking if you did enter 42. So if we did enter 42, I only execute the block in the if statement. I don't execute the block in the else part. So what happens, no matter what I input, I'm going to execute one block or the other. It's not the case that I'll execute both of them or none of them. Exactly one of them is going to be executed, which is pretty cool. So that's what an else statement is for. So it's just a choice between if it's true, then I execute one statement set versus if it's false, I execute a different statement set. So this is just a different picture from before. So we come down, we check the condition. If it's true, we go to one statement set. If it's false, we do a different statement set. And there's no way to get both of them here. Yeah, so here's just an example. I hate this first example for reasons you might see. But we can do the second one down here. If some interest rate is bigger than 0, then we do some calculation. Otherwise, you owe no interest. But then you may be wondering, okay, well, what if we have multiple different cases we need to check? So maybe like for lab 2, for instance, so I'm not going to do the entire thing, but suppose we want to group students in terms of their final grade. So let's just keep it easy. 90 to 100 is an A, 80 to 90 is a B, and etc. So what we would want to check is the student's grade in the range 90 to 100? If it is, then we print A. Otherwise, if it's in the range 80 to 90, we print B. Otherwise, if it's between 70 and 80, we print C. And then continue all the way down. So those are something called an if-else chain. So it's where you have multiple if with else if with else if with else if with else if, and then a final else maybe at the end. So let's just see a quick example of this before I'll let you go. So let's just say that instead of checking for 42 here, let's just say that y is the grade that the final numerical grade that the student got. So if y is at least 90, then we should see out, let's just say A to make it easy. If we just did an else by that, then anything less than 90 will be filtered down into here. But I only want to filter currently the things between 80 and 90. So what should I do here? So all I should do is check against 80. Because if it's less than 90, I'm going to come down here anyway. So if it's between 80, let's just say 89, then it'll be filtered down into this if statement down here. So let's just see this actually work. Oops. So let's just see this actually work. So let's just enter 92, and then we should expect A. If we put in 85, what should we expect as output? B, and we do. If I enter 79, what should be outputted? Nothing, right? Because here, I don't have a catch-all thing at the very bottom to say, for anything else that didn't work before, I'm going to catch those. So if I enter something that doesn't satisfy any of these if statements, it's just going to fall through. So if we do 79, nothing's printed. So That's why it's very common to have a final else at the very, let's just say that this program's finished. Then, someone home? This final else here is to catch all other inputs that are not caught by the previous if statements. Any questions before we break for the weekend? Yeah.
Can we do multiple like ifs inside the
Yeah.
brackets?
We'll talk about that next time. Yes, yes you can.
Does there have to be a space between the else and the if?
Yes, because they are different keywords here. But there doesn't have to be anywhere else. So I can delete these, but I can't delete that one. Yeah.
Can you do multiple variables like greater or equal to like a certain number?
Yeah, we haven't talked about logical operators yet, where I can say something and something else. We'll talk about that next time. I'll see you all on Monday.